Okay, so if you guys flip over to that second page, the first thing I want you to do is identify if something is growth or decay. So, to look to see if something is growth or decay, we're going to look at the B part of our function. So we're looking at that value right there, the part attached, or the value attached to your exponent. So if you're looking at these first three, if you have a 2, a 4, and a 1/4. We don't care about anything else except the single value attached to the exponent. So if it is greater than 1, it's going to be growth. If it's in between 0 and 1, it's going to be decay. So if we have 2, 2 is greater than 1, that's going to be growth. 4 is greater than 1, that's going to be growth. 1/4 is in between 0 and 1, it's going to be decay. So growth and decay, guys, is not based upon negative or positive values. It's based upon your growth or decay factor. If that number is greater than 1, your value or your numbers are going to increase. If it's in between 0 and 1, every time you multiply that, 1/2 times another half is going to be a fourth. You're going to be getting smaller and smaller. So it's not based, upon negative or positive. It's based upon if it's greater or less than 1. So go ahead and try 2, 4, and 6, guys, right over next to it. I'm going to continue on here, and I'm going to look at number 7. It wants you to graph. So you can tell a couple of things about this graph. I know that if a 3 is attached to my exponent, that this should be a growth function. So it should look something like this. It should be going away from my graph after I'm done. I also know that it's positive, so it should be above my x-axis. If it were negative, it would be flipped below. So all we need to do here, guys, is plug in some values. Now, when it says your y-intercept, all that wants you guys to do is plug in 0 for your x, and that's what you're always going to do because your y-intercept is on your y-axis, which means you don't go left or right any. So for your y-intercept, you're always going to want to plug in 0, and you have to find y. Your horizontal asymptote is if something is being added or subtracted. So if something were being added or subtracted here, and even if there's not, you can always write plus 0. So that you think, oh, okay, nothing's being added or subtracted here, so my horizontal asymptote is going to be at y equals 0. So I just do a dashed line there to remind myself, okay, my function is going to get really, really close and get smaller and smaller values, but it's never going to actually touch or cross that asymptote. So it is at y equals 0. Okay, so let's plug in some values. And again, guys, it's okay to get decimals here. You guys just have to know how to plot them. So for this example, it picks values for you guys, which is nice. So all you have to do is say, okay, I'm going to plug in -1. So then let's do that. So y equals 1/3 times 3 to the power of -1. And remember that -1, guys, would make it go into the denominator. So this is really 1/3 times another 1/3, which is going to be 1/9. But I will write it as a decimal so we get used to writing or graphing these decimals. So when I plug this in, y equals 0.11. So then you need to plug in 0. So y equals 1/3 times 3 to the 0 power. Anything to the 0 power is 1. 1 times 1/3 is 1/3, which is also 0.33. Plug in 1. So 3 to the first power is 3. 3 times 1/3 is 1. 3 squared is 9. 9 times 1/3, or 9 divided by 3, is 3. And 3 cubed is 27. Divided by 3, or multiplied by 1/3, is 9. So now you guys have to graph these. So again, it's going to be really, really close to that asymptote, guys, but it's not really ever going to actually touch. So -1 is going to be at 0.11. So -1, and we're just going to put right there. And then at 0, it's at 1/3. 1, 1, 2, 3, and 3, 9. I don't know if my graph goes up that high. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can sort of squeeze it in there, I guess, if we want. It'll be somewhere up here. So as you guys can see, at just the small value of 3, I'm already off my graph. So these exponential, when someone says something grows exponentially, they mean it grows rapidly. And that's why my values get so high so quick. So when you guys are graphing this, you can't pick values like 7 or 8 or 9. You're going to probably have to keep them smaller. So let's go ahead, draw or connect our dots. And again, that line, guys, just goes right along the bottom there and runs along it. We're not a calculator. We can't draw it perfectly, but that's as best as we can do. Okay, so then we have to do your domain and range, and we just found the y-intercept. When we plugged in 0, we got 0.33. I'm just going to write... Again, you can leave it as a fraction or decimal, it doesn't matter. So the domain will be -infinity to +infinity, and the range goes from bottom to top. So your lowest point is 0. It doesn't actually ever touch 0 or reach 0, and it goes up forever and doesn't stop. So it's going to go towards negative or towards positive infinity. So that's number 7, guys. I would go ahead and try number 8, or you just can continue watching this video. I'm going to do number 10 with you guys. So you guys are going to be responsible for doing 8 and 9. So let's go ahead and do number 10. Okay, so for number 10, again, it gives you the values. So we just have to plug them in. So for your y-intercept, again, you're just going to have to say, okay, what is y when we plug in 0 for x? And your horizontal asymptote, that's what's being added or subtracted. So if you have that +1, that's where your asymptote is going to be. This whole function is going to move up 1. So your asymptote is now that imaginary line that your function approaches but never actually touches is going to be at +1. So what that means is that your range, because this isn't negative, it's not going to be below your x-axis, your range is going to go from 1 instead of 0 to positive infinity. And your domain for exponential is always -infinity to positive infinity, which you'll see when we're done. So if we plot these points, we just need to plug them in. So we would, in our calculator, do 2 times 1/3 to the power of -1 minus 2. And make sure you guys do actually try this in your calculator. Make sure that you understand how to put in the exponents properly. So -1 minus 2 would be your exponent, so your exponent should be -3, and then plus 1. So when you guys plug that in, you get 55. So that's what I'm saying. These get so big so quick. So just because you have one that doesn't fit on your graph, guys, don't worry about it. As long as you have 2 or 3 that do, then you're okay. So if you guys plug in 0, so 2 times 1/3 to the 0 minus 2 plus 1. So you get 1/3 to the negative second power times 2 plus 1, and I get 19. Again, you can't graph it. That's okay, but we do know that at least that would be our y-intercept if someone asked us. So then we need to plug in 1. So 2 times 1/3 to the 1 minus 2 times 2 plus 1, I get 7. So I think I can graph that one. So over 1, up 1, 2, 3, 4, 5, 6, 7, up here at the tippy top. Then I plug in 2, I would get 3. And plug in 3, I would get 5/3, or if we're leaving it as decimals, 1.6. So 2, 3, and 3, just a little over 1.5. And that's 2.5. 1.5. And it's not, be careful, don't do what I just did. You don't want to count from your asymptote, you want to count from your actual axis. So then it just comes down right along that asymptote and continues on. So, not too much to this, guys. You just have to be careful that you're knowing that your domain for exponential growth, because it's always going to go both directions, left and right, will always be negative infinity to positive infinity. And your range is always based off the horizontal asymptote. And I'm going to write HA a lot for horizontal asymptote, guys. So just get used to that horizontal asymptote, HA. Horizontal asymptote. So there you go. So go ahead, try number 8 and 9, guys, and see how it goes.